Okay, kids, welcome back. This is our second session on statistical measures. Last time we did mean, median, and mode. This time it's going to get a little harder. Okay? So go ahead and get out your math journals. Like we always do, we have quite a few terms that you're going to need to write down today and familiarize yourself with. So I have the terms already written up here for you. So go ahead and start writing these terms into your math journal or on a piece of paper if you don't have your math journal at home, just so you can have it and redo it. The other thing you could do is snap a picture. If you can take a picture of this and then you can type it out, print it out, whatever you need to do. Okay, the first word we're going to talk about on our list here is quartiles. It says values that divide the data into 4 equal parts. So that makes sense because this first word, quarter, quartile, quart, we know if we're thinking about a quarter of something, 1/4 of something, we split it into 4 equal parts. We'll talk about this later on the easiest way to do that. Okay? The second new term that you have here are the first and the third quartiles. Well, when you split something into quartiles, you're going to have 4 of them. We're really going to be concentrating on the first quartile and the third quartile. So it says the medians of the data values less than the median and the data values greater than the median. Okay, I know, that sounds really complicated. That makes no sense at all, probably. But think about this. Last time, we found the median, which is the one in the what, Colby? What's the median?
The one in the middle.
It's the one in the middle. So when you find the median, you find the middle. Well, all the first quartile is the middle of the first half. So once you split it in half with the median, now we're just going to find the middle of the first half, and then the third quartile, we're just going to find the middle of the second half. Get it? So the first quartile is really just the middle of the first half, the median of the first half, and the third quartile is the median of the second half. So that's going to kind of give you a little bit of a hint on how we're going to find quartiles. We're going to split it in half. And then we take that half that we just split and we cut that in half again on both sides. And now all of a sudden you have 4 pieces. Okay? That's how we're going to find those quartiles. All right. Now, whoa. Yes, this word. Interquartile range. We're going to simplify it and we'll say IQR once we get familiar with it. The interquartile range. What in the world are we doing here? I know, this seems really strange right now, but it's going to all make sense, I promise. Okay? So the interquartile range is the distance between the first and the third quartiles of the data set. Okay? So when we're able to find the first and the third quartiles, which is the middle of the first half and the middle of the second half, we want to know how far is it between those 2 quartiles. That's the interquartile range. The distance between the first quartile and the third quartile. It might have made a little more sense for me to explain this word first, maybe. The range. This one's pretty easy. This is the difference between the greatest and the least data value. So if we have a set of numbers, you can even look at these numbers down here. We got from 0 to 7. What's the range? It's the difference between the greatest and the least data value. So what's the difference between 7 and 0? 7 minus 0 is? 7. So the range for this one is 7. Now look at this set of numbers right here. It goes from 0 all the way to 75. What's the range of this data? 75. Pretty easy when you start with 0, right? We'll work on that some more. But that's the range of a set of data. How far it is from the lowest piece of data to how far it is to the greatest piece of data. That's the range. That makes sense. Okay, wow, look at the definition on this last one. It's called an outlier. Okay? An outlier is a data value that is either much greater or much less than the other values in a data set. Now I'm going to stop right there for a second before we write the rest of it. Okay, I've got a set of numbers. If I was in my classroom right now, I would have us raise our hand on, I would say something like, how many siblings do you have? Hold it up on your fingers. And the kids around the room would hold up, you know, I've got 3 siblings, I've got 1 sibling, I have no siblings. I had a young lady a couple years ago, she held up this, and we went, you have 9 siblings? Oh my goodness, and she did, she had 9 siblings. So we would get a set of data, and then we would ask, we'd say, okay, are any of those numbers way out there? And on that day, everybody had like 2, 3, and 4, right? And she had 9. Does that seem way out there? It's pretty far out there. We go, do you think that might be an outlier? It lies outside of the norm. And we're like, that could be an outlier. All right? So that's mainly what we're thinking about when we think about an outlier. We've got all these regular numbers, and then there's one number that just doesn't seem to belong. Okay? It's an outlier. But there is an actual way to find out if it's an outlier, because sometimes it's really close. You're not sure. You're like, I'm not sure if that's an outlier or not. Well, there's a way to find out. And here it is, the second part of your definition here. If a data value is more than 1.5 times the value of the interquartile range beyond the quartiles, it is an outlier. Okay. Just write that down right now. I don't expect you to understand that yet. But once we get going and I work you through the process and you start to figure out what the quartiles are and you start to understand the interquartile range, the IQR, this will make a lot more sense. But you're going to need it written down so you can come back to it. So you can come back to that. Okay? So, hopefully you've got quartiles, first and third quartile, interquartile range, which is the IQR, range, outlier. You have those written down. I don't expect you to have them memorized, but you have them down. Okay, now let's look down here at the bottom. Okay, let's look down here at the bottom. I have a couple of examples here that we can look at a little bit of just where you might mark these things out. Okay? So if we're looking at this set of numbers, I already put them in order from least to greatest for you. All right? So we have an example though. We have 0, 1, 2, 2, 3, 4, 5, 6, 6, 6, and 7. Okay? The first thing that you should know how to do is find the median. Dalton, the median is the one where?
In the middle.
The one in the middle. So you can see here, we have 1, 2, 3, 4, 5 numbers on the left, and we have 1, 2, 3, 4, 5 numbers on the right. That makes 4 our median. Does that make sense, Colby? That's easy, right? Now, we have, this is our first half of our data, right? So if we're going to find quartile 1, it's really just the median of the first half of our data. Well, how many numbers are there? 1, 2, 3, 4, 5 numbers, right? So we're going to have 2 on this side and 2 on that side. That makes 2 our first quartile. Can you see how that's the median of the first half, Dalton? 2 is the median of the first half of those numbers. Okay, that's why it's quartile number 1, and we just circle it. Okay? Now, look at the second half of our data. We have 5 numbers over here too. So we have 2 numbers on the left, 2 numbers on the right. That gives us 6 as our median of that data. So that is the third quartile. That's the middle of the upper half of data, right? Okay, now if we were going to find our IQR, our interquartile range on this set of data, Colby, how far is it from 6 to 2?
Well, you just subtract 2 from 6.
Exactly. You subtract 2.
4.
It's 4. So our interquartile range on this set of data would be 4. Okay? I told you it sounded a lot harder than it was. That wasn't that difficult, was it? Okay, it just takes some steps. You had to find the median basically 3 times, and then once you found what each quartile was, then you just subtract them, and that gives you your range. So our interquartile range would be 4 on that one. Okay, example number 2 is a little bit harder because it has a different number of data pieces. So we have 1, 2, 3, 4, 5, 6, 7, 8. So where's our median at? Our median is in between 2 numbers. Can you see that? 4 pieces of data to the left, 4 pieces of data to the right. So it's in between 25 and 30. Which one of you could tell me? I know I have the answer right here. But what math would you do to find out? You both know? All right, Dalton, go for it.
So you'd add 25 plus 30, which equals 55, and then you divide it by how many you're adding up. So it's 2. So 55 divided by 2 equals 27.5.
Perfect. So he just took the average of these 2 numbers to find the middle. Yeah. You add 25 and 30, divide by 2, you're going to get 27.5. That is your median. Okay, and remember, that's 27.5 is not a number in my data set, but it's still your median because it falls in the middle. Okay? Now, that leaves us 4 numbers to the left and 4 numbers to the right. So on these 4 numbers to the left, again, we got to find our median. 2 to the left, 2 to the right. Again, our median is in between. It's in between 1 and 8. So what do, Colby?
We have to find the average of 1 and 8.
So we do what?
So we add them together, which is 9, and then we divide 9 by 2, which is
4.5. Our first quartile, again, 4.5, not a number in our data set, but it is our first quartile. Okay? So that's our first quartile. We got 27.5 as our median. We do the same thing on the right side. These numbers are much bigger over here. We would add 50 and 70 in our third quartile and divide by 2 to get 60. Sometimes, can you guys visually see what's in between 50 and 60?
Yes, because 60 plus 10 is 70 and 60 minus 10 is 50.
Right, so there's different math ways you can find this middle, but the most efficient and the best way, you'll always get the right answer, is add them both together and divide by 2. But sometimes you can just see what is in the middle, okay? It's easier. All right, so now we've got our definitions here of our quartiles, and let me ask you something, because this happens all the time. Where's the fourth quartile? I thought we were splitting it into quartiles, which means fourths. How come I only got a first and a third? Let me ask you, where's the second one?
The median?
Okay, good, Dalton. The second one is the median, right? First quartile, second quartile, third quartile. Colby, where's the fourth one?
Well, wouldn't it be like on a number line when you only have like 3 lines, but you have 4 spaces in between? So like the first quartile is from 0 to 4.5. Second quartile is from 4.6 to 27.5. The third quartile is from 27.6 to 60. And the fourth quartile is from 61 to 75.
Excellent. And I even like how she varied the numbers to go to the next one. Perfect. That's exactly what it is. You only have really 3 lines, but you have 4 pieces, like she just explained to you perfectly. All right. Very well done. So that's why you'll never really see us write down fourth quartile. We just know it's this last section. Okay? We're only writing the third quartile to kind of point where that other median is. Okay? All right. Now, what we're going to do is we're going to practice a little bit. Okay? So I'm going to stick this right over here so we don't lose it. We can come back to it. Okay? I have a few problems here for us to do that hopefully we can work out together. And then we are going to find these things for each data set that we're doing. Okay, we're going to find the range, we're going to find the median, we're going to find the first and third quartile, we're going to find the interquartile range, the IQR, and then we're also going to find the outlier if there is one. Sometimes there's an outlier, sometimes there's not. Okay, I'll stick this right back here for right now. We'll come back to that in just a second. Okay, so get out your whiteboards. We love our whiteboards. If you have one at home, perfect. If you don't, that's fine too. Okay, I'll put this over here to kind of get rid of that glare for you a little bit. Okay, here's our first data set. Number of text messages sent. Now, this is the question back to our statistical measures. When we have a data set, what do we always want to do first?
Put it in order from least to greatest.
We want to put it in order from least to greatest. Yes, we do. So let's do that. What was our other tip that we got from Mrs. Byrd last week? Dalton.
Count how many numbers you have and then make sure you have the same amount when you write it down.
Perfect. Okay, so let's do that too. All right, so I'm going to write mine in order from least to greatest. You guys do it, and let's make sure that we get it right. I could make a mistake. You might have to help me out here. All right, so I've got... Oh, that pen, it's not working so good. Let's try this one. Okay, I've got 10 numbers. I counted 10. Is this what you guys have? You got 56, 57, 58, 59, 60, 61, 62, 64, 67, 71.
Yes.
Okay, you can make a mistake right there. We try not to because that's an easy one, but let's not make a mistake right there. All right, now, if you noticed, I didn't want to cross them off anymore because I didn't know if you were still working on them, but I always have to have some sort of way of checking that I used that number already. So you can see me, I just made like a little dot or whatever to kind of show that I used that number to make sure that I had them all. All right, now we're looking first of all for the median. Okay, so I know that I have 10 numbers. That's going to leave me 5 numbers on each side, right? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So that puts my median right here. I will usually do that. I don't know why, that's just my habit. I draw a line in the middle, okay? I like to have my middle really obvious to me, and I want to know where it's at. So there's my median, quartile 2, median, whichever one you want to do, all right? Now, I'm going to try to find quartile 1. So I got to find the middle of these 5 numbers. Well, that makes it pretty easy. 2 on the left, 2 on the right. So 58 is my quartile 1 right here. Okay? And then, again, over here I've got 5 numbers. 2 on the left, 2 on the right. So 64 is my quartile 3. Can you guys see it? See how that works? I've got my median. Then this is really just the median of this set of data. And this is the median of this set of data. Quartile 1, quartile 2, quartile 3. Okay. So, what's next? We're trying to find... we found the median. We found the first and third quartile. Let's find the interquartile range. Let's find the interquartile range. So, Dalton, do you know what we're going to do?
Yeah.
Okay, what are you going to do?
So you're going to take the third quartile and the first quartile, and you're going to subtract the first quartile from the third quartile.
Excellent. And what did you get? You subtracted 64 minus 58, and you got?
6.
6. All right, very good. So our IQR right here equals 6. Okay, very good. Now, I kind of forgot right off the bat. What is our original range? What is our range for this whole set of data? Colby, what would you do?
Do 71 minus 56.
Okay.
Which is 15.
All right, excellent. So our range, our overall range, I'll put that over here, is 15. Okay, so we found the range, we found the median. Oh, but I didn't ask you this. What is the median? I found where it is, but we didn't say what it is. You both know, both of you at the same time. What is it?
60.5.
Perfect. Okay, our median is actually 60.5. Yes, it is. Very good. Okay, these were easy because they were already done for us. All right, so we found our range. We found quartile 1, quartile 3, the IQR, the interquartile range. We found the median. Okay, we've almost found everything. But let me ask you this. Just looking at this set of data, does it look like there's an outlier? Does it look like there's one line way out there? Or are all these numbers pretty close together?
I think they're pretty close together.
I think it's pretty close.
I think you both are right. They're pretty close together. Now, if we looked back at our definition, it would have to be 1.5 times our interquartile range. So 6 times 1.5 would be? 9, exactly. It would have to be 9 further than 64. Is 71 9 further than 64? No, it's only what? 7 further. Okay? So it's not out of our realm. And then it would have to be 9 less than 58. 56 is only 2 less, right? Okay, so if we were going to have an outlier on this set, it would be something like, you know, anything above like 75 in the 80s, that would be an outlier, or anything like in the 40s would be an outlier. But on this set of data, we don't have an outlier. Get it? All right, perfect. On this next one, let me make sure we did all of these. Okay, we answered the range. We got it, right? Yep, 15. The median, we got it, right? Yep, 60.5. First and third quartiles we got. First was 58. The third was 64. The IQR was 6. And the outliers, there were none. All right, very good. Okay, on the second set of data, I want you to do this one on your own. This is minutes of exercise. Okay, so on the minutes of exercise, all right, I want you to do that on your own. And let's see what you get there. I'm going to do it like this so you can remember what you're looking for while we do this here. You're trying to find all 5 of these things. The range, the median, the first and third quartile, the IQR, and then outlier if there is one. to start writing. As you guys, I can see, are already well ahead of me. I'm going to start to put mine in order. Okay, are you about there? All right, let's start with our median. Actually, let's start with our range. Right here, we'll go down the list like we're supposed to here. What was your range of the overall set of data?
50.
50. 90 minus 40, our range was 50. Perfect. Good. All right, next we had the median. Now I wrote where it was, but I didn't write it down. What did you guys write was our median?
50.
Well, our range was 50.
So it doesn't really matter.
Okay, it doesn't matter. Could all of our answers be 50? They could if every single number we used was 50, right? All right, yeah, sure. So our median is also 50. Very good. Okay. What about our first quartile?
45.
You both have 45. Me too. What about our third quartile?
60.
Yep, I've got 62. What about our IQR, our interquartile range?
15.
15. Yes. Okay. And then we have one more thing to think about, an outlier. When you just look at this set of numbers, does it look like one of them doesn't belong? Which one, Colby?
90.
Why? It's what?
It's, 30 more than 60.
Yeah, it's 30 more than our next biggest number. And all of these are not that far apart, right? You know, this is 5 apart. These are the same, 10 apart. You know, this is only 20 from here to there. And then from there to there, you got 30. So we're pretty sure it's an outlier. Okay? We're so sure that we're going to write it down. But let's check it just to be sure. Okay, go ahead.
So you have to do 15 times 1.5, which is 22.5.
Okay.
And then you have to see, it has to be 22.5 greater than 60.
It has to fall in that group. And 90
is, it's 30 more, so
it's
greater.
Outside of our room.
And
Yep.
you would have to have something 22.5 less than 45, but 40 is only 5 less. So
All right. So 90 is our only outlier. Great. Okay, that leads us to a good question. Could we have more than one outlier?
yes.
Sure. We could have had a really small number and then a really big number. We could have had 2 really big numbers, and they could have both been outliers, right? Sure, you can have more than one outlier, but we did have an outlier. Okay, on this last problem that I want to show you down here, okay, go ahead and erase your board. These numbers are pretty big, but I want it to kind of make sense to you, and I'm hoping that this example will help it make sense to you. Because you might be thinking to yourself, finding the average of something, sure, we use that all the time, right? Finding the mean, you know, teachers use it. We use it in all kinds of different things. Finding the mean. Maybe even finding the median. the one in the middle. That makes sense when you have a big data set, you're finding the one in the middle. Or finding the mode, the one that occurs the most. That might be helpful, all right, for, somebody. But why in the world would we need to find the inner quartile range? Is that hard for you to think about right now? Why would we go to all the trouble to find the inner quartile range? Why not just find the mean? The average. Why not? Why do we need to find the range of the middle, two sets of data and then cut it down to fourths and then find the middle of it? Why do we need to do that? Do you have any idea?
No.
Okay, good. That's what I want to try to help you with right now by giving you one real life example of why we might do that. Okay, think about home values in a neighborhood. Okay? We could use our neighborhood right here, but the kids that I'm teaching in my class aren't really familiar with that. Let's just say we go a little bit south of Cedarwood. Just go down Temperance a little ways south. Okay? There's a neighborhood there with, I'm sure some of our kids live in it. Let's just say, this is not completely accurate, but we're just going to use these numbers. A lot of the houses are worth about $250,000. 250, 275, 200, 250. Well, then there's this one house that's not really in the neighborhood. Okay? And it's on like this big lot. And it's this huge house. And it's kind of there by itself. It's worth $895,000. It's almost worth $1 million. This house is really big and really nice. Okay? And then on the corner, there's this old house. It was like the first house ever in this whole area. In any of the neighborhoods, it's really old. Okay? Really old. And it's really small. Okay? And it's only worth $100,000. Now, I want you to think a little bit, Dalton. Are you ready to think? If I'm the realtor, okay, and these are the houses that just sold in your area, and you come to me and you say, I want to sell my house, all right, I'll say, oh, let's just take an average of all the houses sold in your area. Does that make perfect sense?
No.
Okay, what's the problem with that?
We have a really big house that's going to bring your average way up. And you have a really small house that might bring it down a little bit.
Okay, so if I'm selling my house and my realtor takes the average and she throws this in there and I'm going to be like, oh yeah, let's sell my house for a whole bunch more money. But that doesn't make any sense, does it? Because if I'm the person buying the house, I'm like, I'm not paying that much. All the houses that look like yours sold for this much. Why are you averaging in $895,000? Well, that house is just right there. It's in the same neighborhood almost. And it's sold. No, that doesn't make any sense, does it? Now, if you think about this on an even much bigger scale, what we're doing with an interquartile range is we're really narrowing it down. And we're getting rid of all the low ones, right? And we're getting rid of all of the high ones. And we definitely want to get rid of the what?
Outliers.
Would this be an outlier?
Yes.
Would this be an outlier?
Yes.
Okay. So we definitely want to get rid of the outliers. So if your realtor is checking all the houses that sold in your area, she might want to find this interquartile range because it really narrows it down to the middle of the houses that are like yours, that have sold, that are, like the house that you're living in. And some, why would this one maybe sell for $275? Well, maybe it has a pool. Maybe they put in a brand new kitchen. But it's still really close to this one, right? It's not, this much different. So when you're finding your interquartile range, it can help you in something like this, to get rid of the really lows and the really highs and really narrow your average or your focus down. And that's why we might use something like the interquartile range. Okay? Now, go ahead and do this one. Okay? Yes, those are big numbers, but it doesn't change that much. They're easy numbers to work with. Okay, count your totals. Make sure you have 7 in your new list if you had 7 in your old list. Now, sometimes this happens when you run out of space like I did. I don't have a nice streamline, so I'm going to have to really be careful that I find my median, right? Okay, so I've got 7, so that's going to leave 3 on one side, 3 on the other side, and that's going to leave my median right here in the middle. This is my median. Okay, now I've got 3 on this side, so that's going to leave the one in the middle here as my quartile 1. And that's going to leave the one in the middle here, 1, 2, 3. This one here as my quartile 3. Okay, my range which one has the range? Do you have the range?
No, not
I
yet.
have it.
How much was it called?
795,000.
Correct. 795,000 was my range. My interquartile range was much smaller. Galt, did you get the interquartile range?
No, not yet.
Okay, I'll wait for you. I think we're going to be surprised at something here. Are you surprised at something, Colby?
Oh,
That's going to be our outliers, or outlier. Okay, Dalt, what do you have for the IQR?
25,000.
Now read what you have. Our IQR is quartile 3 minus quartile 1.
Oh, I get the median. Oh, it's 75,000.
75,000. There you go. That's the IQR, 75,000. Colby, what do you know about our outlier?
well, I'm still working on it.
Okay, keep going. you know that our IQR is 75,000, so what are you doing? You're timesing it by?
1.5.
All right, good. You got it.
I changed my answer.
Okay, what did you just change your answer from?
Well, at first I thought that the outliers would be 895,000 and 100,000.
So did I. And?
But I did 75,000 times 1.5.
Yeah.
And it's 112,500.
Okay.
And there's only 100,000 between two.
Right. So this actually is not an outlier. It's still within the realm by just a little bit, by 12,000. Okay, but is 895,000 an outlier?
Yes.
Yes, it's way over. All right, so we only had one outlier, when just by looking at it, we thought that we might have two. So sometimes it is helpful to figure it all the way out. Okay, great job. So there's your lesson on interquartile range, another form of statistical measure. Okay, hopefully now you guys can find all of these different things for a data set. You can find the range, the median, the first and third quartile, the interquartile range, and the outliers. All right, good luck, and we'll see you again next